Today the topic of discussion is in array address calculation. We'll study how to calculate address of multi-dimensional address calculation. Prior to this, we have seen how to calculate 1D address. Then we have seen 2D address, that is row major order and column major order, row major order, and then we have seen column major order. Now we'll see multi-dimension. What do you mean by multi? What we mean by multi-dimension is that means when there is more than 2 dimension, that is 3 dimension, 4 dimension, 5 dimension, n dimension we talk about. Fine. Okay, so let's start with multi-dimension. So multi-dimension array address calculation. So I have taken this concept, this diagram or this language from again TMS, Tata McGraw-Hill. So it's one of the standard book. So what is 2 dimension? 5x4 matrix. This is what 2 dimension. And if I say some dimension is 5x4x3, this is 3 dimension. If I say 5x4x7, this is what? 4 dimension. Similarly, this is what trying to tell you. Given a multi-dimension array are defined analogously. More specifically, an n-dimension array where m1, m2, mn are array B is a collection of m1 into m2 into mn data elements. Why? Suppose you have a matrix and you have a 5x4 matrix, and if I say there are 5 rows and 4 columns, how many elements are there? So element will be 5 into 4, 20 elements. Similarly, if a matrix is of dimension m1 into m2 into m3 into mn, so how many elements will be there? So multiplication of this, so this is what it's showing, that m1 into m2 into mn data elements will be there. Fine, is specified with an integer sub. Now what is k1, k2, kn? Where you were calculating the address. When you were calculating the address, you were calculating address of 12 comma 3 in 2 dimension. So this was j and this was k. Now you have to calculate the address of suppose 12, 3, 4, 9, 7 or 5 of 5 dimension matrix. So what is this? k1, k2, k3, k4, k5 and dash dash kn. So similarly, this k1 is our subscript where you need to calculate the address, with the property that always remember this k should be less than m1. This is very true. Suppose I have a matrix of 5x4 and I am calculating the address of 4x3. This is perfectly fine. But if I am calculating the address of 6x3, this is perfectly wrong, because this index should be less than this index. Fine. Similarly, if I am calculating k1, then k1 should be less than m1 but greater than 1. K2 should be less than m2 less than 1. This is m1, m2 all about. Fine. Okay. And if you want to calculate the address, then this is the way. This is what I told you. This is the way of calculating the address. Now, what is the representation of 3 dimension? I told you 1 dimension. I told you 2 dimension. Now, if you want to see 3 dimension, see 3 dimension. So, in 3 dimension, there is a row, first row. There is a column, first column. And this is a page of first page. First row, first column, first page. First row, second column, first page. First row, third column, first page. Then first row, first column, second page. First row, second column, second page. First row, third column, second page. This is third page. First row, first column, third page. 3 will remain same. Similarly, this dimension is what page is all about. So this page remains keeps changing, and you keep changing the dimension. Fine. Okay. So, and if you want to see the figure, so again, either it's 1 dimension, either it's 2 dimension, either it's 3, either it's 4, either it's n dimension. It will be either stored column wise or stored row wise. So you have already understood row major order and column major order in 2 dimension video. So when I was going through 2 dimension video, I told you everything very clearly what is 2 dimension video. Now we will discuss same thing. Now we'll discuss same thing, this row and way in 3 dimension. So let's start with something which we have already discussed. So generally there are 2 types of array. So we have already discussed in video number 1, that is in 1 dimension. We have a 2 type of array, regular array. What are regular array? Whose index start from 0 or 1. Suppose A10. So A10 either start from 0 to 9 or you can start from 1 to 10. So these are regular array. What is non-regular array? Whose index start from other than 0, 1. That is if this is the array. Then in this case it start from -5, that is lower bound is -5 and upper bound is 2. So this is regular and non-regular array. First concept. Second concept, length of array. What is length of array? Upper bound minus lower bound plus 1. Suppose you have array A10. So what is upper bound? Suppose it's starting from 0. So upper bound will be 9. What is lower bound? 0 plus 1. So 9 minus 0 plus 1, 10. Fine. Yes, A10 has 10 elements. If considering 0 as lower bound. If you use A10 having index 1 as lower bound, then upper bound will be 10. 10 minus 1 Upper bound minus lower bound plus 1. Again, you are getting 10 elements. So it's 100% same. Either you are starting from 1 or you starting from 0. You get the same number of elements. Now, suppose for this element, for this array, you want to calculate the number of elements. So what is upper bound? Upper bound is 4. 4 minus lower bound. What is lower bound? Minus 5 plus 1. So when you calculate this, you again get 10. So here is the method of calculating. For 2 dimension, what is the number of element? 5 for 4 matrix. So 5 into 4, you have 20 elements. So these are method of calculating what number of elements, or number of elements, if you can. Address of any element of multi-dimensional array having dimension m1 m2 mn, because it's a multi-dimension. No, if it is a multi-dimension, definitely there will be more than one two. In case of 2 dimension, what we took 2 comma 3, 2 cross 3. So this was 2 dimension, but we have n dimensions, so this will be m1 cross m2 cross mn using, this is very important, column measure order. The calculated formula, the order calculated using formula. How to calculate? What is the formula? The formula is this. Now this formula seems quite big and very confusing, but I am giving you assurance. I'll make you understand how this formula is, and I'll try that you can remember it longer time. So let's start with formula. Then first is location of A, K1, K2, Kn. What is K1, K2, Kn? If you have seen my video of 2-dimension array, where we have calculated address of A 12 comma 3, where 12 comma 3 was what? This was J and this was K. Now because now my address, my array is n dimension. So suppose I have 12 3 4 dash dash 9. So what is this? This is K1, this is K2, this one is K3, and this one is K4. So this is what K1, K2, K3 is all about. K1, K2, Kn is all about. So this will be Kn, I'm sorry. So this is what Kn all about. Now, the first part is same, base address plus W into. Now you can see that En, Ln minus 1 plus En minus 1. What this En and Ln is all about? First, let's see what is En and Ln. Ei is effective index. Ei, where I could be put as n also, 1, 2, whatever you want. Ei is effective index, where the formula is Ki minus lower bound. So what is Ki? We have just seen that this one is K1. So if you are calculating E1, so E1 will be K1 minus lower bound. And what is lower bound? Lower bound of first part of matrix. Fine. And what is length? We have just seen length here, that upper bound minus lower bound plus 1. So L1, L2, L3. By this we can calculate the length also. Now you have a formula. Let's see the formula. The formula is En ln minus 1 plus En minus 1 plus into ln minus 2. How this formula is, and how we can remember this formula. So let's start. First of all, En, then multiply En with 1 less than En, that is n, then ln minus 1. Then add En with same subscript of L, that is En minus 1. Then multiply again. If you are multiplying E with L, then multiply with 1 less, then it will be ln minus 2. Then similarly it will go, and at last it will reach E3, then it will be multiply L2, then it will be added with E2, then it will be multiplied with 1 less and added with same. After that there will be no scope. Fine. So this is the formula of column measure order. But right now you must be confused how to use this formula, what you are talking about. So in next slide we are going to solve one question, and I'm giving you 100% assurance that in next slide you will understand this formula very clearly. Now you have a multi-dimension array address calculation using column measure order, and the question is this. Suppose 3-dimension array A is declared using. So you have a 3-dimension array. This array is of type non-regular array, which we have already explained. So this is non-regular array. This is first part, second and third. Fine. Okay. Now you have a non-regular. Suppose the array is stored using column measure order. Suppose it is stored using column measure order. Base address is 200. Word length is 4. You have 2 questions. Calculate the number of elements in array A. Now first question is how many elements are there, and then address of this. So in order to calculate the number of element, we have to calculate length of each dimension. So we have 3 dimension, 1 2 3. So calculate the length. And what is the formula of length? We have just seen Li is equal to upper bound minus lower bound plus 1. Now put, if you want to calculate L1, then upper bound, the first dimension upper bound is 8 minus lower bound 2 plus 1 will give you what? 7. Fine. Then calculate L2. Upper bound is 1 minus lower bound, which is minus 4, plus 1 will give you what? 1 plus 4 will give you 6. Fine. L3, upper bound, that is 10, minus lower bound, that is 6, plus 1 will give you 5. So finally what you did, you calculated L1 as 7, L2 as 6, and L3 as 5. Fine. Okay. Now I'll rub this because I need a space, so I'm rubbing this. So you have calculated this. Now what is number of element? No, obviously if you have a two-dimension matrix, fine, the element it's of 5 cross 4, so number of element is what? 5 into 4. What is 5? Length of one dimension. What is 4? Length of second dimension. So when you multiply, you get the number of elements. So 5 4 20, there are 20 elements in the matrix. Similarly, you have calculated the length, so you have a length, so number of element will be L1 into L2 into L3, which is L1 is 7 into 6 into 5, which is 210. Fine. 6 5 30, 30 into 7, 210. Fine. So number of element, which is 210. So you have solved this question. So number of element you have 210. So finally you have solved this question, that number of element you have 210. Now your second task is to calculate address of A5 minus 1 and 8. Now what you will do? So you know the formula. Again, I'll show you the formulas. This was the formula where you have to calculate location of A, K1, K2, Kn. What is K1, K2, Kn? This one is K1, this one is K2, and this one is K3. Fine, because we are using 3 dimension. Now, as we have already calculated L1, L2, L3, now we have to calculate E also, E1, E2, E3, because we have 3 dimension. So what is the formula of E? EI is equal to Ki minus lower bound. So E1 will be equal to K1 minus lower bound. What is K1? 5. So put in formula. So 5 minus lower bound of first dimension. What is the lower bound of this dimension? 2. So you put 2. So 5 minus 2 will be 3. Then E2 is what? K2 minus lower bound. So it is, what is K2? You have K2 as minus 1. K2, and what is the lower bound of this? Minus 4. So minus 4 will give you what? Again 3. And E3 will be K3 minus lower bound. What is K3? 8. What is lower bound here? 6. So you have 2. So what you did, you calculated E1. So I'm writing here, you calculated E1 as 3, you calculated E2 as 3, you calculated E3 as 2. Fine. So finally you calculated this. Now you have calculated everything. Your job is to just put in the above formula. If you see the above formula, above formula of column major order start from n. So what is n? The number of dimension. Here number of dimension is 3. So it will start from 3. So the formula will be something like that: base address plus W into E3, because n value is 3. E3 into L2 put. Then En minus 1 again E2, then Ln minus 2 put n value 3, 3 minus 2 is 1, L1 plus E1. No, fine, E1, because this has same thing. Now multiply with L0. There is no concept of L0, so our formula will stop over here. So finally our formula will stop over here. Now put the value. Now you have everything in your hand. Now you put the formula. Now you put the value in the above formula. Base address 200. What is W? 4 into what is E3? What is E3? E3 is 2. So you put 2. Fine. Into L2. What is L2? L2 is 6. What is L2? 6. What is E2? 3. Fine. Now multiply with L1. What is L1? 7. Now add E1. What is E1? E1 is 3. Fine. So 3, L2 is 6 and L1 is 7. Fine. Now calculate. 200 plus 4 into 2 6 12. 12 plus 3 15. 15 into 7 is 105. 105 plus 3 108. Now you multiply 108 with 4. This will give you 400, and then 8 with 4, 8 4 32. This gives you 432, and when you add 432 with 200, you get 632. So finally 632 is what answer of this question, column major order. So finally what column major order is? 632. Fine. So you know, now I hope just prior to this slide you might be finding this formula very tricky. So it's very easy. How? Remember this. You start with E3, multiply one less, add same, multiply one less, add same, and keep on doing like this. Fine. Okay. Okay. Now let's see the row major order. Everything remains same. We have already discussed this part. Now address of any element in using row major order is this one. So what is the change over here? The change is very slightly, very little change. That everything remains same. What happened? There you started with en. Here you start with there you started with decreasing order. Here you start with increasing order. E1, then multiply with 1 greater, L2, then add same. This will remain same. Multiply 1 greater, add same, multiply 1 greater, same. Then you will reach to En minus 1, multiply 1 greater, and add same. So you have finally reached here. Fine. Okay, and at last I'll show you the same question which we have solved prior, but now you have to solve the same question using what? Using a row major order. I have written this you have to solve using row major order. So it's my task to you. It's a homework. You just solve it, and let me know in a comment box that what is the answer. So at last I'll say